This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website. This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Good morning, everyone. Welcome to week 2 of Land and Property Economics. I hope you enjoyed listening to the first lecture where we discussed about the concept or the definition of land and property economics. And today we will look at these topics. I don't intend to scare you with answers straight away, so I will remove the answers and rather focus on the questions that we will look today. So we want to discuss that how is the price of land determined and what are the factors that affect the supply of land and what are the factors that affect the demand of land. If you recapture from your economics lessons, price is determined with interaction of demand and supply. And therefore, to understand price, it will be important to understand how supply of land operates and how demand of land operates in the market. In general, with man-made commodities or commodities which are not natural but are produced with intentions to, be supplied in the market. These include capital goods and any other good for consumption, food, products, and any product you name in the market that is available in the shelf in any store is a man-made product. So with man-made commodities, price is usually a function of demand and supply. But here we are talking about land, which is provided to us by the nature and is available in fixed supply if we consider pure land, that is the surface of the earth. So then we are thinking, it is important to think that the supply is fixed for land, and we say that the price is a function of demand and supply. So how is price going to be determined when supply is fixed? And what do we mean when we say the supply is fixed? We mean to say that land as a whole, meaning the entire land mass on this earth, can be regarded as fixed in supply. We don't have another earth available yet. We also don't have Mars accessible to us. So essentially land is fixed in supply. Unless we consider reclaimed land, which is viewed as a capital good and not as land per se, because it is very capital intensive to produce that land. So it becomes a capital good rather than land, which is often considered as supplied by the nature or provided by the nature. So the idea of land as a whole being fixed in supply is important in all discussions of cost and value of land. And we will try to understand this concept of supply being fixed in more detail before we start discussing the demand. Now, here I'm trying to recapture some basic concepts of market equilibrium. So what do we mean by equilibrium? Equilibrium is a situation from where no one has an incentive to deviate from. It's a situation where there are no forces or reasons for change. So when we are talking about equilibrium price, it is the price at which market clears and demand meets the supply. At equilibrium price, the consumer gets precisely the quantity of the good they are willing to buy at the price they are willing to pay, and the producer or the seller precisely gets the quantity they are willing to sell at the price they want to sell. Similarly, equilibrium quantity is determined when the quantity demanded and supplied are at the equilibrium point. Here it is represented by point E naught, which is the intersection of the demand and supply curve. So at this point, the quantity demanded and quantity supplied both is equal to QO naught. Also, the price demanded by the consumer and the price at which the seller wants to produce or sell is same and is P naught. So we are referring to the y-axis for price and x-axis for quantity. These are the basic concepts and graphs for economics, just to recapture. Now, here we are looking at three different scenarios to understand equilibrium price and quantities for normal goods which are not fixed in supply as opposed to land. So let's look at case 1, where we are talking about a good that is not fixed in supply. And we just discussed this case where demand is the gray curve, D1. The demand curve is always downward sloping, which means to say that as price increase, quantity demanded reduces. The more expensive a product is, the less we want it. Opposite to this is the supply curve, which is upward sloping, which means that when prices increase, the quantity supplied increases. The more the price of a commodity, the greater benefit it generates for the supplier, and therefore the supplier wants to produce more quantity. The point of intersection of demand and supply, which is point L in this graph of case 1, is the equilibrium point where demand meets supply and the market clears. We are discussing a scenario where demand changes or increases from D1 to D. A rightward movement in demand indicates an increase in demand, because if you focus on the intersection point of demand curve D1 with supply E naught and the intersection point of demand curve D with supply, that is E1, you will realize that at point E naught, the quantity demanded was Q naught at a price P naught. But when the demand increases, the quantity demanded Q naught is now demanded at price P, corresponding to demand graph D rather than D1. So the price increases when the demand increases and the supply is increasing. It's not fixed, it's increasing. So what happens is that when the demand curve D1 moves forward and demand increases, a new equilibrium E1 is found. So the equilibrium changes from E naught to E1, and at the new equilibrium, quantity demanded is Q1 on the x-axis and price demanded is P1 on the y-axis. Since the demand has increased, so the equilibrium price P1 has also increased from P0 to P1. And since the demand has increased, the quantity demanded has also increased from Q0 to Q1. So the equilibrium quantity and equilibrium price for the new demand, increased demand, is greater than the equilibrium price Q0 and equilibrium price P0 for the earlier demand D1. This is a case when the supply curve is forward sloping, which means that the supply can change from Q0 to Q1. Different points on the supply curve represent different quantities corresponding to different prices. Now let's look at the case of land. When demand changes from D1 to D for land, which is fixed in supply, the supply curve is just a straight vertical line, indicating that the supply is fixed at quantity M. The supply can't change. We understand that the mass of land on Earth is fixed. So if we assume that we have M quantity of land available on the planet, so the supply is fixed, and irrespective of the change in demand, the supply doesn't change. And therefore, the price on y-axis is solely determined by the demand graph. This is to say that the equilibrium point, which in this case is L, at the intersection of demand curve D1 and supply curve, this intersection point doesn't change unless the demand curve changes. And corresponding to this intersection point, the quantity will always be fixed and the price will only change if the demand changes. There is no change in quantity, the supply is fixed, and therefore price becomes solely the function of demand. This is the case of land. Unlike other commodities where supply is flexible and when demand changes, a new equilibrium is found with a new quantity and a new price. And then price becomes the function of both demand and supply. But in this case, price is solely the function of demand because supply is fixed. This is very important for us to remember that the supply for land is fixed. Land is provided by the nature and therefore the cost of production is zero. We are not producing land. And when we say we are not producing land, we are not talking about reclaimed land. As we already discussed, reclaimed land would be considered as a capital good because it's very capital intensive product and it is not considered land, which we assume is provided by the nature. So land is provided by the nature and therefore the cost of production is zero. We can put this another way and say that the opportunity cost of production is zero, meaning to say that we are not losing anything in producing land because in the first place the cost of production is zero. So there is no alternative good we are giving up to produce land. It's already existing at no cost of production. Therefore, if there is something generated from the land, by something I mean an asset which has monetary value, or if there is earning from land, then that earning is actually in excess over the opportunity cost, or this earning is in excess to the production cost, which is zero. The earning for some user who has demand D1 is R1O Q1L, the rectangle, and earning for someone who has a demand for land represented on curve D would be ROQ1N, the bigger rectangle. Now, why would people demand land? They would demand land only when they can use it for an economic purpose. Otherwise, they would not. When we say economic purpose, it could well be for their consumption. Let's say, for example, for growing food. But then there is always an implicit cost of food that can be calculated, even though the person himself or herself consumed it. So let's say if I'm user 1 and I'm growing agricultural crops on my land worth R1O Q1L as a area, So my total earnings would be R1 in monetary terms, and for a land, I would be happy to pay this much rent so as to be able to generate the resource I need. Similarly, if I have earnings equal to R, then I will be happy to pay earning equal to R for the use of land. Now, why would I pay the full earning? Because we are assuming a very competitive market. In a competitive market, the profit reduces to zero, which means that you end up paying the full profit. I mean, profit above your normal profit. Again, we will discuss normal profit in a while. So, in a competitive market, there is no profit because it's a competitive market and users compete against each other and the surplus is paid as rent or additional rent. So in this case, we are assuming, and we will always assume, that the full earning would be the rent that the user would be happy to pay for the land, for the use of land. So in this case, R1 and R represent rent for user 1 and user 2, or probably for the same user if the demand changes for the user from D1 to D. If the demand changes, that means the same user is able to use land more productively and is able to generate a rent greater than R1, which is represented by R here. Now the interesting thing is that since the supply is fixed and the opportunity cost of land is zero, so even if the earning is very small and minimalistic, it is still positive. I mean, it is a positive number. Anything greater than zero is still positive. And if we translate it on the supply graph, the quantity demanded will still remain Q1, which is fixed. However, in ideal circumstances, when the price on y-axis reduces, the quantity supplied reduces and tends to incline towards zero. But in the case of land, the quantity supplied will be Q1, which is fixed, irrespective of howsoever small the earning is. And this is very important to note. Given the fixed supply of land, price is the function of demand alone, and we will keep emphasizing upon this fact. So we understood that the opportunity cost of production of land is zero, and price is solely determined by the demand alone. However, it is important to note that saying that opportunity cost of producing land is zero and that the earning of land are a surplus over opportunity cost does not mean that the payments do not have to be made for land. There is still a land rent to be charged, and land rent is a periodic payment for the hire of land, and it performs a vital function in rationing scarce supply among competing users and competing uses. To explain simply, let's take a scenario of a normal commodity which is not fixed in supply. Say, for example, bread. So the sale price of a commodity like bread would be equal to the cost of production and the profit of the firm or the manufacturer who is producing it. We are assuming normal profit here. So summing the profit and the cost of production, we get the sale price of the commodity. In case of land, similarly, the rent of land will be the cost of production of land plus earnings generated from using the land. Given that cost of production is zero, so the rent of land equates to the earnings from land. And this is what we have been talking earlier, that rent for land is equal to the earning from land. Even though the opportunity cost is zero, there has to be a rent to be paid for the use of land. Now, we talk about rent and payment of rent only when we assume that land is scarce, it's not amply available, and people need to hire land from other users. So then the concept of rent will be easy to understand. There is a landowner, and then there is another user who wants to use land, and the user will pay certain rent to the original owner to use land. And that rent in a very competitive market, or in a perfectly competitive market, would equate fully with the earnings from the land. Again, revising some basic definitions of economics, we have been using some terms here. If you remember from the first lecture, we were talking that land is a product in itself, and it is also a factor of production. So when we say land is a product in itself, we mean to say that land exchanges hand as raw land and is useful as raw land itself. And land exchanges hand also because it can be used to produce other assets. Like, for example, all the improvements on land in the form of residential buildings, commercial buildings, or industrial buildings, warehouses, and whatever we construct as an asset on land uses land as a factor of production. So factor of productions are the inputs needed for the creation of a good or service. And land is very well a factor of production. It's an input that is required for the creation of those goods and services because they have to be footed on the land. They can't be floating in the air. And three major factors of production include land, labor, and capital. At times we also include entrepreneurship, and at times we actually exclude some of these things and merge them together. But the three major factors of production commonly that are discussed across economic discipline are the land, labor, and capital. Also, we have been using the term opportunity cost earlier when we were saying that the opportunity cost of production of land is zero. What do we mean by opportunity cost? It is actually the cost of the best alternative opportunity foregone. Here, probably I would like to give an example. Let's say I have $3,000 to be spent on something which I prefer to use or which adds to my well-being. And I'm thinking that either I should buy a new laptop or should I pay for one additional subject and enhance my skills, or should I go for a holiday? So holiday is not an option at the moment given the COVID environment and travel restrictions. So that option is out of window. The two options remaining are laptop and additional subject. So if I put them in the sequence of priority, my priority would be to buy a laptop. The second priority would be to take an additional subject. And the third priority would be to opt for a holiday, which is not an option at the moment. Anyway, assuming that if that would have been an option, then my priority list is 1, 2, 3, laptop, subject, travel. Now the opportunity cost of a laptop for me is to let go taking additional subject, which would enhance my skill. The opportunity cost for me is not the travel, but only the next best option, which is to take additional subject. The opportunity cost for me is also not the sum of option 2 and 3 that is foregone. It is only the next best alternative that is foregone, which in my case would be an additional subject. I hope this explains this opportunity cost to you. If not, then of course you can refer to the book by Stiglitz called Principles of Economics. Production cost, we have also been referring to this term that the production cost of land is zero. Actually, this refers to the cost incurred by a business or firm for manufacturing a product or providing a service. This is a technical definition, and production cost may include a variety of expenses, including land, labor, and capital. So, production cost is essentially the sum total of all the cost incurred in the production of a good or service. There are some important points to note at this stage. So, first we have already said that opportunity cost of producing land is zero and that the earning of land are a surplus over opportunity cost. This does not mean that the payments do not have to be made. We still pay the rent for land, which equals to the earning from land. How do we determine the rent to be paid? And at the moment, we are focusing on the supply side. We have started discussing supply first, and later we will take the discussion on demand. So, of course, there is a discussion of supply and demand happening simultaneously here, but we will keep it simple by considering only two demand curves and looking at how supply changes, what will be the impact of supply on the rent. I think it will become more clear as we move forward. So let's look at case 1. I'm assuming here that the supply of land is fixed, which is Q1 on the x-axis. We are also assuming that land can be used only for one use or one purpose, which is agriculture in this case. We are also assuming that there is only single user and there is no other user existing. That user may have a demand of U1 or U2, depending upon what is he growing as an agricultural product. So the demand for land will change depending upon the product which he is using land to grow as an agricultural product. So let's focus on DU1, the demand curve. So DU1 intersects with the supply curve at point N. And if DU1 is the use for which the user is willing to use the land, then the earning from use 1 or the earning for user 1 from agricultural use would be R, read on the y-axis corresponding to point N, and the quantity Q1 is fully used for generating this kind of rent, R. So the rectangle ROQ1N encloses the earnings from land fully when quantity 1 is fully used for purpose represented on demand U1, DU1. Now, if the user is using the land for another crop for which the demand for land is represented on curve DU2, then the point of intersection of demand curve on the supply curve is L, which is lower than N. And if that is the case, then the earning from land would stop at R1, which is lesser than R. Now, any rational user would want to use the land optimally, and therefore user 1 as a single user would pay only rent R and not rent R1 and would use land for a better use, which in this case is represented by DU1. So on the horizontal axis, we see that user 1 is using the full amount of land for use, agricultural use, for which the demand is represented on DU1. This is a monopoly situation where there is only one user. We will discuss about a situation of competition, but before that, let's see another graph here. Again, a monopoly situation of single user, but here we are relaxing the option that land can be used for multiple uses and not just agriculture. These different uses could be residential, commercial. Here we are assuming only two uses possible for land. One is commercial, one is agricultural. Again, the supply curve is a straight vertical line and the quantity is fixed at Q1. Now, the demand curve for agricultural use is dA, represented by the green curve, and that intersects with the supply curve at point N, corresponding to generating rent equivalent to R. On the contrary, the demand curve for commercial land is steeper and it intersects the supply curve at point L, and rent corresponding to this point of intersection is R1, which is lower than the rent for agricultural use. We observe that there is a point, or there is a stretch where DC is greater than DA. However, since we are assuming that there is a single user, so the single user would use the full land for only one purpose, and therefore we are assuming that he would use the land for agricultural purpose only, because at the point of intersection, given that he has to use the entire quantity of land Q1, the point of intersection N generates greater rent than the point of intersection with commercial land use, which generates lower rent. So if there is only one user, there is no competition, he or she would want to use the full land for agricultural use. Let's see what happens if we relax the assumption of monopoly and talk about two users. Now, in this case, we are assuming that DU1 is user 1 and DU2 is user 2, and there will be some competition among them. Now let's observe the demand curve DU2 and DU1 more closely. In the first case, where land is still used only for agricultural purpose, or rather there is only one single land use. So we observe that the second user can generate greater rent between quantity OQ2, but the first user, read on DU1 graph, will generate greater rent than DU2 between quantity Q2 and Q1. So the total quantity is still Q1, but the first user generates greater rent between quantity Q2 and Q1. So the first user would want to pay higher rent than the second user between the quantity of Q1 and Q2. So the rent for land between quantity Q2 and Q1 would be determined by the demand generated by user 1. But why would user 1 pay anything more than rent R, which is the rent he would generate where his demand curve intersects with the supply curve? So given that the demand curve for the second user is much lower, the first user would want to pay only this much. which is R. He would want to pay only this much up till a point where the second user, DU2, exceeds in his earning and generates more return than R1, which is represented by point O here. So look at point O. At point O, the second user's earning would exceed the earning of R by first user, and to be able to outbid the second user, the first user would have to pay extra rent along the line OP. This user would want to pay only as much high as to outbid user 2, and therefore he would not exceed OP. He would only pay as much as user 2 and outbid him. However, beyond point P, the first user would not be able to outbid the second user because his earnings are lower, the demand curve is lower, and therefore beyond point P, the second user would start paying rent equivalent to his earning. So the full rent picture is given by the shaded area, where the rent for land between quantity Q3 and Q1 would be R. Between quantity Q2 and Q3 would be determined by plotting rent corresponding to the demand curve of U2, and between P and the y-axis intersection, again the rent will be determined by drawing lines on the rent axis corresponding to the demand curve for user 2. Now this is a situation where there are only two users. Similarly, if we are talking about two different uses and two different users, it is probably a bit simpler to understand, because here we are saying that the second user would want to use the land for commercial purpose and the first user would want to use the land for agricultural purpose. The concept is similar again, since for commercial land the demand is low when the quantity is higher, that is between Q2 and Q1. So the demand is high for agricultural use between quantity Q2 and Q1, and therefore the rent generated by agricultural user would be greater than the commercial user between quantity Q2 and Q1, and the rent therefore would be determined by the earning, agricultural earning, which corresponds to point N at R rent. So the first user will continue paying rent R up till point O, where the rent for commercial use increases beyond this dotted black line, and to outbid the commercial user, the agriculturalist would still pay a higher rent equivalent to the commercial user, but not the total he is earning. He will still save some. And, beyond point P, the rent for agricultural user is lower, represented by dA, and therefore the rent for land will be determined by rent corresponding to demand for commercial land. So the shaded area, a combination of blue and green, would be the determinant of rent. This is how the rent graph will look like. Let's go forward and discuss the realistic scenario. Again, the most realistic scenario is case 2 here, where the supply is fixed, there are multiple uses of land, and there are multiple users of land. However, before we talk about the case 2, we will talk about case 1 where the supply is fixed, but we are talking about only a single use. And it is important to understand single use. We will come to it in a while, that why is it important to understand single use scenario. So again, we are assuming the single use to be agriculture. There is user 0 who doesn't generate any rent. There is user 1 who generates rent corresponding to the demand curve du1. And there is user 2 who generates rent corresponding to the demand curve du2. Now, earlier we said that there is only one user, and therefore du1 was paying rent equivalent to R for up till the point of intersection of du2 demand and Rn dotted line. Because beyond this point, the earning for du2 was higher, so du1 had to match this. But before this point of intersection, du1 was the sole user, so he was trying to save this gap between his demand curve and the corresponding earning if he was using the full land, as we see here. So there is a gap here. But if there are multiple users who are using land for the same purpose as du1 and are generating the same earning as du1, then they will be competing against each other. So for the same use, there are multiple users and they will be competing. And this is a real market scenario where the competition is perfect, and therefore each will try to outbid the other by consuming the surplus profit or earning. In doing so, in a perfect market competition, people will consume their surplus fully to outbid each other, and therefore the rent will be determined corresponding to points on the graph du1 up till point P. Beyond point P, the rent will be determined corresponding to demand curve du2, which is higher than du1 beyond point 2. And therefore, the rent for land will be the outer boundary of the shaded area of green, solid and hatched. Here we are saying that for the same use, land can generate different earnings for different users when used relatively intensely through investment of capital. Like for example, we were saying that du2 is generating more earning beyond point P as compared to du1. So probably he is using some technology, some technique, or is investing capital on land in a way that he is able to generate more earning up till quantity 2. So if we are talking about rent differences when land is used for the same use, then those differences may arise even when the land is used for the same use, because people will invest different amount of capital in land and use it in different level of intensity. And by doing so, they will generate different level of earnings. And therefore, by using this land for same use, but with different intensity, people can generate different kind of rents. So competition among users for the same use does exist in the real world. In a perfectly competitive market, price of land would be equal to the economic rent or highest earning possible for any user. Now let's move to look at the perfect market competition when there are multiple users. Again, we are saying that the supply is fixed, and we are considering a scenario where there are two users, but there are multiple users. So the demand DC represents the demand for use type 1, land use 1, maybe a cumulative demand for all users. And demand curve dA represents the cumulative demand for all users who are agriculturalists. Now what happens is that between quantity Q2 and Q1, the demand curve for agriculturalists is higher than for commercial users, and therefore the rent is determined corresponding to prices on the y-axis when read on the curve dA, starting from R and going up till, say, this point here, where P corresponds to y-axis. Beyond point P, the rent will be determined by the commercial users who are competing against each other and therefore paying every penny they are earning in paying for the rent. So in this case, land can generate different earnings from different uses, say agriculture, residential or commercial. And in a perfectly competitive market, price of land would be equal to the economic rent or highest earnings generated by the highest and best use possible. Here the point of intersection P is the point where the use of land changes. Now, how do you relate it to the real life scenario? We understand that planners do zoning, and when doing so, they have to determine that how much quantity of land should be allocated for what kind of use. So we know here that if we know the demand curve for different uses, we would understand that what quantity of land would be demanded for a particular kind of use. So here OQ2 is the quantity demanded for commercial use, and between Q2 and Q1 is the quantity demanded for agricultural use. Now the interesting thing to note here is that even though the supply of land is fixed, existence of different uses and different users implies that the supply of land can never be regarded as fixed from the viewpoint of any one use. So here we can always interchange, or we can always borrow more from one use type and give to the other use type. And that is what we do when it comes to regulations of land use. While market would determine OQ2 use for commercial, we at times encroach upon the agricultural land and we allocate more for commercial. That means that there is a possibility to interchange the supply, or there is flexibility of supply within uses while the total supply is fixed. It's like cutting a cake in equal pieces. So if you are cutting it in 4 equal pieces and allocating to 4 different people, here let's say 4 different land use types, then it's perfectly fine. But you can always change the proportion in which you want to allocate to 4 different users or 4 different uses. However, you cannot change the size of the cake. You can only change the proportion in which you will allocate or supply to different users or consumers. So that's what we are saying, that the full size or full supply of land as a whole is fixed, while we can do the division of supply from within or across the uses, and there is flexibility. So we cannot regard the supply to be fixed from the viewpoint of any one use, unless that is the only use existing. Like for example, in this case, we were assuming the only use to be agriculture. So while there are different uses, but the use type is same, so there is no flexibility. All land has to be used for agriculture. But here we are talking about 2 different use types and having the flexibility and opportunity to change the supply or quantity of land supplied for different uses. So we are saying that additional supplies can always be bid from other uses if the proposed new use has a higher value than the existing use. In this case, if the demand curve for commercial would have been higher to a certain extent, then it would have been economically beneficial to allocate additional land for commercial use. And otherwise, if we forcefully do that, we are actually enforcing land to be underutilized for a use which is less productive than a use which is more productive, which we should not do. Now, up till this point, we were actually discussing about the supply side of land. We were talking about supply to be fixed. However, there is flexibility of supply when we talk about distribution of land across different uses. Now we are talking about demand of land. Now the commercial rent for land as a factor of production and derived demand. When we say derived demand, we are meaning to say that land is a factor of production. We are considering land as a factor and not as a product itself. When land is a factor of production, then it is demanded for its contribution in the production of other assets like houses, offices, industries. And therefore, the demand for these other assets would indirectly create demand for land, and therefore it is called the derived demand, which is derived from the demand of the products which are produced by using land. We already discussed that the rent for land is a periodic payment for the hire of land, and it is determined through competition among users and uses by interaction between demand and supply. Now we will focus on those elements which impact upon the demand of land. We have already discussed supply. Supply is fixed. There is flexibility to allocate quantities across different uses. Now we are focusing on demand, and we want to understand what factors impact upon the demand of land. So we are, as we said, that we are talking about land as a factor of production or as an input. So the quantity of land demanded by a firm would depend on the price of land relative to other factors of production, that is capital and labor, the productivity of land for a particular use, and the price of final products. To explain these, we will use the isoquant technique, and I will explain a few basic economic concepts to you before we move forward and discuss these points and the isoquant technique. So let's flag these questions here, and we'll come back to them after we have understood the basics of the budget constraint and isoquant. Please bear with me. This is a bit intensive. I can understand that. But once understood, these concepts will remain with you for the rest of this subject, and it will help us in understanding other theoretical concepts as we move forward in the subject. These are interesting things, not difficult, and most of the representations here or which economists do are graphical, not numeric. So we don't have to worry about number calculations. We only have to understand the logic. Now, what do we mean by budget constraint? There is fixed income and fixed budget for production of goods. Here, again, in economics, we talk about households and firms. So, households talk about income and having a budget constraint of income, and firms will have the budget constraint in terms of the income available to them that can be used for production of goods. I think I will explain these things again. At the moment, these are the broad definitions, but I will explain them as we move to the next slide. To give a broad picture, a budget set is the affordable set of all possible bundles that a consumer or firm can afford. Budget constraint or the budget line is the set of all possible bundles that exactly exhaust consumer's income at a given price. And anything that lies outside the budget constraint is unaffordable. I'll explain this to you in a while. So let's try to understand the budget line first. And first we will make an assumption that a consumer, a person like you and me, has a fixed income, say dollar B. And there are two goods that the consumer can buy, good X1 and good X2. Also, let's assume that the price for X1 is P1 per unit and the price for X2 is P2 per unit. So the budget constraint would mean that the total budget, if I'm not saving anything, we are assuming that there is no saving. So the total budget would allow the person to use X1 quantity at price P1 and X2 quantity at price P2, and the sum of the two should not exceed the budget. Otherwise, it is unaffordable. It should also not be lower than the budget, because then you are underutilizing your income because you can't save. There is no incentive saving. That's the assumption. So you should use the budget fully. So you can distribute this budget between two goods which are valued at price P1 per unit and price P2 per unit. If represented graphically, the budget line would look like this, where we are representing quantity of good X2 on the y-axis and quantity of good X1 on the x-axis. So this is the budget line, which is represented by this equation here. What would be the slope of this budget line? We know that the slope is rise upon run, or y-axis upon x-axis. So the rise, or the vertical intercept in this case, which will be somewhere here at point here. So I think I should move the points to make it easier for you to understand. Let's say this is X2 and this point here is X1. It's easier this way. So yeah, so the slope will be rise upon run, which is OX2 upon OX1. Now what is OX2 here? The quantity of good 2. Now how will you determine the quantity of good 2, the maximum quantity of good 2 that you can consume? That is, when the quantity of good 1 is 0, the quantity of good 2 that you can consume will be determined by this equation. So if X1 is 0, then the quantity of X2 would be total budget divided by the price of good 2. Therefore, OX2, or the y-intercept, would be budget B divided by the price of good 2. Similarly, if you are not consuming any quantity of good X2, then you are consuming fully X1, or you are consuming your budget fully for X1. So how much amount of, or how much quantity of X1 can you buy? That will be determined by the total budget divided by the price of commodity 1. So if we have to derive the slope of this line, we will divide OX2 by OX1, which is B by P2 divided by B by P1, and we get the ratio of price of commodity 1 to price of commodity 2. So the slope of budget line is the relative price of good 1 to good 2. This is simple. Now let's get back to the things which we were talking earlier about budget set. Now this is the vertical intercept, this is the horizontal intercept, this is the budget line, this is the slope. Any expenditure within this line is possible and affordable. And this is called your budget set. Any expenditure outside the budget line is unaffordable, and you don't have enough income to spend like this. On the budget line, all combinations fully exhaust your income. And this is what you should be spending when there is no incentive saving. So the best and most efficient would be to be on the budget line. Within the budget line, you are underutilizing your income, and outside the budget line, you can't afford. So the best you can do is be on budget line. Now you can have different combinations of quantities of good 1 and good 2 by being on the budget line, and the extreme combinations are point x2 and point x1, where you consume your budget fully in consuming quantities of good x2, and you consume your budget fully in consuming quantities of good x1. There is a small typo here which I'll correct, going so that you have perfect slides when you are reading and you are not confused. Okay, there we go. So we understand that the optimal utilization of budget would be to consume quantities while being on the budget line. Okay, now let's look at some scenarios. How does the budget line move if the income increases, which is the case 1 here, where we are trying to understand the impact of increase in income on the budget line. We are saying increase in income, which means that the ratio of price or the price of good 1 and good 2 is not changing, and therefore the ratio of price of commodity 1 and commodity 2 is not changing, which is also the slope. So essentially the budget line will move parallel and outward. If the income is increasing, which means your budget B is increasing, so you would be able to consume more of good 1 and good 2, or a combination of both, with the increase in budget. There is another scenario where we want to talk about the impact of increase of price. I'll pause here for a moment. Okay, so we were discussing the second scenario, that what happens when the price of a commodity changes. In this case, let's say the price of commodity 1 is changing. Again, there is a small typo, and I will try to correct that. So we are saying that the price P1 changes from P1 to P1 new, and P1 new is greater than P1. So the price of commodity 1 is increasing from P1 to P1 new. So if the denominator here is increasing, then the value of B divided by P1 new would reduce and will come inward. So the quantity of good 1 that a person can buy at the new price would be less than as compared to when the price was lower. So the budget line, which joins the extremes when consumer can buy only quantity 2 to when the consumer can buy only quantity 1. So the budget line moves inward and becomes steeper. This point doesn't change because the price of commodity 2 is not changing and the total budget is not changing. But this point comes inward, moves inward, and therefore the line becomes steeper, and the new slope will be determined by the price of commodity 1 relative to the price of commodity 2, the new price of commodity 2. Similarly, an increase in price of good 2 would make the budget line flatter, because if the prices increase, this point will come down, and when joined with the original point here, it will be flatter. So these are the impact of change in price and change in income on the budget. We will use these concepts as we start discussing about the demand for land and the factors which impact upon the demand for land. So when we were revising the basic concepts, we have talked about budget constraint, and now we want to understand what are isoquants. Those of you who understand basic economics, isoquant curve is companies or firms' counterpart to the consumers or households' indifference curve. So it is more like an indifference curve, but not for the household or the consumer, but for a firm or a company. So what it means is that it is a curve, a convex curve, downward sloping, which connects all the points at which the same quantity of output is generated, while the quantities of input change. For example, if we have land as one of the factor of production, and we combine capital and labor as other factors of production, and we need to understand that in what proportion should we use other factors and land, then on the isoquant line, these different proportions in which land and other factors can be combined would generate the same amount of output. Say in this case let's assume that in this case we are using land for residential purpose and for production of apartment units, for example. So EP10 means that by combining capital and labor and land in different quantities, we are generating 10 units of apartments, and by varying the combination, we are generating 10 units on this isoquant line. If we break down the term isoquant, in Latin it means equal quantity, where iso means equal and quant meaning quantity. Now, if you want to understand more about isoquants, then I have included a link here. To access the video fully, you can log in using your student ID using this link and then access the video fully. It will explain you what isoquants mean. Now, the important thing here is to remember that we can combine different factors of production and land in different proportions, in different quantities, and on one isoquant curve, these different combinations end up giving the same output, or in this case, different portions of land, labor, and capital when combined together will give the same output of 10 units on this curve. So it's a way of representation. As we move outward, the isoquants improve. So by moving outward, we are saying that by combining other factors and land, we are generating 30 units on EP30, we are generating 20 units on EP20, and we are generating 10 units on EP10. So as we move inward or closer to the origin, the output reduces. In this graph, we have tried to draw the budget constraint line along with the isoquant line, because we understand that the combination in which we can combine other factors and land is determined by the budget. As we discussed earlier, budget line is the constraint on budget. So if we use the full budget on other factors than land, then we will be able to demand QC2 quantity of other factors. If we use the full budget for land, we will be able to demand QL4 of land. And again, we are assuming the total budget available to be B and price of land to be PL. So QL4 will be equal to budget B divided by the price of land, and QC2 will be equal to budget B divided by the price of all other factors combined together. Within this blue line, there are combinations possible, but optimal utilization of budget would be when we are on the blue line. So optimal utilization of budget will be on the blue line, and optimal production we are assuming is EP2. So therefore, the optimal quantities at which the other factors and land should be used is determined by the point where the budget line is tangential to the isoquant line of EP2. One assumption we are making here, which is that between EP10, EP20 and EP30, we are assuming that EP20 is profit maximizing for the developer, given the budget constraints. So we would want to generate, or the firm would want to maximize profit and would want to be on the isoquant line. So the firm would want to be on the isoquant line EP20. The firm would want to be on the budget line. So the only possible combination is the point where the budget line is tangential to EP20, and at this point, the quantity of land that should be used is QL3, and the quantity of other commodities or other factors of production would be QC3. So let's try to understand that EP10, EP20 and EP30 are the isoquants, which will yield outputs of 10, 20 and 30 units of accommodation respectively. By joining QC2 and QL4, we get the budget line. Slope of the budget line is determined by price of commodity L, which is land, and other factors. And the total budget when spent wholly on land will give quantity of QL4 equivalent to B divided by the price of land, and total budget when used for good other factors, then it will generate quantity QC2. We are assuming that EP20 as the profit maximizing output, which means that 20 units when produced will be most profitable for the developer. And the cost minimizing factor combination for EP20 level of output lies on point A on the budget line, that is QC3 and QL3. Now assume a different scenario, that if the profit maximizing output would have been EP30, then you would have required a greater budget than the blue line. And greater budget means the line will move parallel, but the slope will not change, because the prices of commodities and the prices of factors of productions are not changing. So the line will move parallel, and we will be requiring the firm will require a greater budget if EP30 was the profit maximizing output. But we are not considering that, because we are assuming that EP20 is the profit maximizing output. any combination of budget within this budget set or the triangle enclosed as O, QC2 and QL4 is possible. However, as we move inside the triangle, the point tangential to isoquant curves would yield lower return or lower outputs than the profit maximizing output of EP20. Therefore, we would not want to be inside. We would want to be exactly on the budget line. There are some assumptions being made here. Everywhere we are assuming that land is homogeneous. It doesn't have properties, different land parcels doesn't have different properties. They are all homogeneous. And buyers are only interested in maximizing private utility or monetary returns. These are the usual assumptions we make. Conditions of demand and supply do not change. And the output at which profit is maximized is known to us. And in this case, we are assuming that to be 20 units. So these are the general assumptions we have made here. Now, we have discussed about isoquants. We have discussed about budget constraint. So let's go back to the questions that we flagged earlier. That how is the quantity demanded impacted by change in price of land, change in productivity of land, and change in price of final products. Again, emphasizing that price of land is a combination of demand and supply. We have discussed that supply is fixed but is flexible in regard to multiple uses. And now we are talking about the demand of land and how does the demand of land changes because of change in price of land, change in productivity of land, or change in price of final products. So let's look at question number 1, that how does the change in price of land relative to other factors affect the demand for land? And when we are talking about the isoquant and budget line, we are talking about microeconomics, which means we are talking about one firm and not a general economy. We are talking about one firm who is dealing with this land, for which the isoquant line looks like this, for which the budget line looks like this. We are operating under the assumption that profits are maximized when 20 units are produced, that is at EP20. Now, what will the change in price of land do? We are assuming that a situation where there is an increase in price of land. So let's read it on the graph. We know that if the price of land changes from PL to PL new, which is greater than PL, the quantity demanded will reduce from QL4 to QL2, and the budget line will become steeper because the price of other factors of production is not changing, nor is the total budget. So the black line is the new budget line if there is an increase in price of land. So an increase in price of land will result in a steeper budget line created by joining QC2 and QL2. At this point, again, there is a slight problem in the visual. So let's move it here. Okay. Yep. So when the budget has changed, we have to be on this new budget line, which is the black line, and the intersection, or rather this budget line is tangential to a new isoquant which is inward from the earlier isoquant and therefore would generate lesser output, say 10 units. So at the new budget line, the output will be lower because the quantity of land is lower while the productivity is same. So due to less consumption of land, the level of output has reduced from EP20 to EP10, because we are not talking about the productivity of land changing. We are only talking about the price of land changing. So when the price has changed, quantity of land consumed has reduced, so has the output reduced. Also, the capital has changed. So we are saying that less land is combined with more capital. This is the impact of change in price of land on the demand for land. So if the prices increase, land demanded reduces. If the prices reduce, land demanded would increase, and an opposite phenomenon would be observed. Now let's go to question 2, that what would be the impact of change in the productivity of land in a particular use? Now, increase in productivity of land. So you remember earlier we were saying that the productivity of land is not changing. Here we are saying that the productivity of land is increasing, but the budget is same. So when the productivity of land is increasing, the isoquant would become steeper. So the same output of 20 units can now be produced in a lesser budget and also by lesser consumption of land. So we are saying that this should be actually EP20 and not EP10. So this is the new isoquant line, which also generates 20 units. So what we are saying is that earlier, when the productivity of land was lower, we were consuming land equivalent to QL3 for producing 20 units. But when the productivity of land has increased, we are consuming only QL1 quantity of land, and that too at a lower budget. So the same output of 20 units can now be produced in a lesser budget because the budget line has moved closer to the origin. And this is achieved by reducing the consumption of land from QL3 to QL1 and also from reducing the consumption of other factors from QC3 to QC1. Now let's try and answer the last question, which is that what will be the change of price of the final product? For example, apartments. What will be the impact on the demand for land? Now suppose there is an increase in the demand for apartments and therefore the price of one standard unit increases. So with the same budget, what will happen is that a new profit maximizing output would now be generated, which will be larger than the original. So we are saying that with the increase in demand and increase in price of the output, the profit maximizing output for the firm will also increase, and a new isoquant outward or in the right direction of the earlier isoquant would be generated. And to match that, one would need a greater budget and one would need greater quantity of land to be consumed. So if there is a change in price of the final product, particularly if there is an increase in price, then more land and more capital will be required to generate a higher level of output. And if there is a decrease in price, less land and less capital will be required to generate a lower level of new profit maximizing output. So with this, we summarize today's lecture. And I would like to recapture upon the questions with which we started this discussion. And I would also like to briefly explain to you what we will do in the tutorial. So we questioned that how is the price of land determined? That was the entire objective of this lecture. And we understand that the price, which is the rent in the case of land, is determined through interaction of demand and supply. Now, what factors affect supply and what factors affect the demand? That is what we discussed. We know that the supply of land as a whole is fixed, but can vary across uses. When it comes to demand, we assume land to be homogeneous and looked at variables that would influence its demand as a factor of production and not as a product itself. In summary, we discussed that an increase in productivity of land or an increase in price of land would reduce the consumption of land. An increase in price of final products would require larger consumption of both land and other factors, and thus a larger budget for achieving profit maximizing level of outputs. Now, so far we have been assuming that land is homogeneous. What we will do in the tutorial is that we will consider the real life scenario when land is heterogeneous, and we will try to understand the variables that contribute to the price or influence the price of land. So that will be an interesting discussion. I'm looking forward to meet you all, and I'll end this lecture here.